we're going to be wanting to rationalize in the denominator. And if it contains only one term, you can be looking at, say, 1 over the square root of 3, is that if you multiply by the square root of 3 divided by the square root of 3, square root of 3 times square root of 3, square root of 9. 1 times square root of 3 is the square root of 3. Square root of 9 is 3, so you end up with the square root of 3 over 3, which means there's no longer a radical in the denominator. So if I were to look at this particular problem, which is I've got 1 over the square root of 2, well, this again is a monomial, so I'm going to multiply by the square root of 2 over the square root of 2. So 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2 is the square root of 4. So I end up with the square root of 2 over 2, and there's no longer a radical in the denominator. Now, if I am dealing with a binomial, which is what we're going to deal with most of the time in terms of rationalizing the denominator, I'm going to multiply, if you remember, by something called the conjugate. The conjugate. It's that same expression with a negative sign in between. So the conjugate of 5 plus the square root of 3 is really 5 minus the square root of 3. So that's where you see multiplying by the conjugate. I'm actually multiplying by 1, which doesn't change the value of the fraction, but actually just changes his appearance. So that's what they did down here. So you'd end up with 5 minus the square root of 3, 5 minus the square root of 3, so that you're going to end up with 7 times 5 minus the square root of 3 over, if you FOIL this out, 5 times 5 is 5 squared. Inner outers add the 0. And then the square root of 3 times the square root of 3 is the square root of 3 squared. So that you get 25 minus 3. So 7 times 5 minus the square root of 3. You can multiply this through or not as you like. And that's where you're going to end up with the radicals gone from the denominator. In this particular instance, the conjugate will end up being the square root of 7 minus 2, square root of 7 minus 2, so that you'll have the square root of 2 times the square root of 7 minus 2 over square root of 7 times the square root of 7, which is square root of 7 squared. Inner is plus 2 square roots of 7. Outer is minus 2 square roots of 7, so the inner outers add the 0. And minus 2 times a plus 2 is a minus 4. So this is the square root of 2 times the square root of 7 minus 2. Square root of 7 squared is 7. Inner outers add the 0, minus 4, which is the square root of 2 times the square root of 7 minus 2 over 3. That is a perfectly good answer. You could also distribute the square root of 2 so that you could end up over 3. Square root of 2 times the square root of 7 is the square root of 14 minus square root of 2 times 2 is just 2 square roots of 2. That's perfectly fine as well. Personally, I like that one far better.